Hello friends, I am Professor Rajendra Koranne from my YouTube channel Teach Easy. In this video, I am going to discuss the MCQs on slabs along with the explanation of answers. So let us start. Question number 1. When the slab is supported on two opposite edges, it is said to be A. One-way continuous, B. Two-way simply supported, C. One-way simply supported, and D. Cantilever slab. Now you know that when the slab is supported on two opposite edges, it is known as one-way simply supported slab. So the correct answer is C. One-way simply supported slab. Question number 2. When the slab is supported on all four edges, it is said to be one-way continuous, B. Two-way simply supported, C. One-way simply supported, and D. Cantilever slab. Now here the slab is supported on all four edges, so it is said to be two-way simply supported slab. The correct answer is B. Two-way simply supported slab. Question number 3. For a one-way slab, the ratio of longer span to shorter span is A. Less than 2, B. Greater than 2, C. Equal to 2, and D. Greater than or equal to 2. Now for one-way slab, Ly upon Lx, that is also known as aspect ratio, that is ratio of longer span to shorter span, is equal to or greater than 2. Hence the correct answer is D, greater than or equal to 2. Question number 4. In a one-way slab, the main reinforcement is provided along A. Shorter span, B. Longer span, C. Both longer and shorter span, and D. None of the above. Now for one-way slab, the bending moment is considerable along the shorter span. Along the longer span, it is negligible, and hence the main reinforcement is provided along the shorter span. Hence the correct answer is A. Shorter span. Question number 5. In a one-way slab, the distribution reinforcement is provided A. To keep main reinforcement in position, B. To resist shrinkage and temperature stresses, C. To resist bending moment, and D. Both A and B above. Now the distribution reinforcement is provided. Now let us see what are the functions. First one is to keep main reinforcement in position. This is okay. To resist shrinkage and temperature stresses, this is also okay. To resist bending moment, this is not okay, because to resist bending moment, main reinforcement is provided. Hence the correct answer is D, both A and B above. Question number 6. In a one-way slab, the distribution reinforcement is provided A. Along the longer span over main reinforcement, B. Along the longer span below main reinforcement, C. Along the shorter span over main reinforcement, and D. Along the shorter span below main reinforcement. Now in a one-way slab, the distribution reinforcement is provided along longer span, that is no doubt. But first, the short span reinforcement is provided, and over that the longer span reinforcement or distribution reinforcement is provided. Hence in this question the correct answer is A, along longer span over main reinforcement. Question number 7. For a two-way slab, the ratio of longer span to shorter span is A. Greater than 2, B. Equal to 2, C. Less than 2, and D. None of the above. Definitely for two-way slab, the ratio is less than 2. Hence the correct answer is C, less than 2. Question number 8. For a two-way slab, the main reinforcement is provided A. Both shorter and longer span, B. Longer span, C. Shorter span, D. None of the above. Now for a two-way slab, along both the direction, the bending moment is considerable. Hence on both direction, the main reinforcement is provided. Hence, the correct answer is A, both shorter and longer span. Question number 9. The trial depth of a cantilever slab is A, Lx upon 20 times modification factor, B, Lx upon 7 times modification factor, C, Lx upon 26 times modification factor, and D, Lx upon 20. Now, basic L by D ratio for cantilever is 7. Hence, the trial depth is calculated as B, Lx upon 7 times modification factor. Question number 10. The trial depth of simply supported slab is A, Lx upon 20 times modification factor, B, Lx upon 7 times modification factor, C, Lx upon 26 times modification factor, and D, Lx upon 20. This is similar to the previous question, only the case is simply supported. For simply supported slab, basic L by D ratio is 20. Hence, the correct answer of this question is A, Lx upon 20 times modification factor. Question number 11. The trial depth of a continuous slab is A, Lx upon 20 times modification factor, B, Lx upon 7 times modification factor, C, Lx upon 26 times modification factor, D, Lx upon 20. Now I think here no explanation is needed. The correct answer is C, Lx upon 26 times modification factor. Question number 12. For a cantilever slab, the main reinforcement is provided at A, bottom, B, top, C, mid depth, and D, side. Now for cantilever, if all the loads are acting downward, it will bend in hogging fashion. Hence, the tension will be developed at top, and we are providing the reinforcement to resist the tension. Hence, for cantilever, the main reinforcement is provided at top. Hence, the correct answer is B, top. Question number 13. The depth of a slab is governed by A, bending moment criteria, B, deflection criteria, C, shear criteria, and D, bearing criteria. Now, for the slab, we know that the trial depth we calculate from deflection criteria, that is L by D. And then after calculating the bending moment, we also calculate the depth required to resist the bending moment. And it is generally seen that the depth required to resist bending moment is much less than the depth required for deflection criteria. Hence, we are providing the depth which we have decided for deflection criteria. Hence, the depth of the slab is governed by deflection criteria. So answer is B, deflection criteria. Question number 14. The depth of the beam is governed by A, bending moment criteria, B, deflection criteria, C, shear criteria, and B, bearing criteria. Now in case of beam, whenever we are taking the depth, we are taking the depth according to the basic L by D ratio. That means if for a simply supported beam basic L by D ratio is 20, we are taking as 15 less than that. That is, we are calculating the depth as L by 15 or L by 14 or L by 12 or L by 16 like that. And then we calculate the bending moment, and then we check whether that depth is sufficient to resist the bending moment or not. So here the main role is played by bending moment, and depth required to bending moment is deciding factor. Hence, the depth of the beam is governed by bending moment criteria. The correct answer is A, bending moment criteria. Question number 15. The minimum area of reinforcement for 120 mm thick slab reinforced with HYSD bar is A, 144 mm square, B, 180 mm square, C, 120 mm square, and D, none of the above. Now the minimum area of reinforcement for slab for HYSD bar is 0.12% of Ag. So if you calculate 0.12% of B, that is 1000, and D, that is 120 mm, you will find that it will be 1.2 times D, and it is 1.2 into 120. So it will be 144 mm square. Hence the correct answer is A, 144 mm square. Question number 16. The minimum area of reinforcement for 120 mm thick slab reinforced with mild steel bar is A, 144, B, 180, C, 120 mm square, D, none of the above. Now here mild steel bars are used. So for mild steel bars, the minimum area of reinforcement is 0.15% of B into D. B is 1000, so it comes as 1.5 times D, and 1.5 into D is 120. If you put that, you will get the answer as 180 mm square. Hence the correct answer is B, 180 mm square. Question number 17. The self weight of a 120 mm thick slab is A, 4 kilonewton per meter, B, 2 kilonewton per meter, C, 3 kilonewton per meter, and D, 5 kilonewton per meter. Now how the depth of the slab is calculated? We have to calculate in terms of UDL. So what is unit weight of RCC? It is 25 kilonewton per meter cube. So 25 into capital D, that is overall depth, but that should be in meter. We are consider 1 meter wide strip, so into 1. So if you see carefully, it will be 25 into 1 into 0.12, and that will come out to be 3 kilonewton per meter. Hence the correct answer is C, 3 kilonewton per meter. Question number 18. The self weight of 230 mm by 400 mm RCC beam is A, 2.3 kilonewton per meter, B, 2.5 kilonewton per meter, C, 2.8 kilonewton per meter, and D, 3 kilonewton per meter. Here also it is unit weight into cross sectional area, that will be the weight in Newton per meter or kilonewton per meter. So here you will see that 0.23 into 0.4 into 25, and that will be UDL in kilonewton per meter, and it will come out to be 2.3 kilonewton per meter. Hence the correct answer is A, 2.3 kilonewton per meter. Question number 19. If the unit weight of BBM, that is burned brick masonry, is 20 kilonewton per meter square, then the weight of 3 meter high 230 mm thick BB masonry is A, 8.8 kilonewton per meter, B, 13.8 kilonewton per meter, C, 6 kilonewton per meter, and D, 3 kilonewton per meter. Here also the unit weight is given, so unit weight into that thickness into height will be the load or weight in kilonewton per meter. So it will be 20 into 3 into 0.23, because it is in millimeter, and that will come out to be 13.8 kilonewton per meter. Hence the correct answer is B, 13.8 kilonewton per meter. Question number 20. The maximum spacing of distribution steel in a one-way slab is A, 5D, B, 3D, C, 450 mm, D, lesser of A and C. Now according to IS 456-2000, we know that the maximum spacing of distribution steel in one-way slab is 5D or 450 mm, whichever is less. Hence the correct answer here is D, lesser of A and C. Question number 21. The maximum spacing of main steel in one-way slab is A, 3D, B, 300, C, 5D, and D, lesser of A and B. Now similarly for main steel, the spacing shall not exceed 3D or 300 mm, whichever is less. Hence the correct answer of this question is D, lesser of A and B. Question number 22. For a slab In general, the depth required to resist bending moment is dash 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 the depth required for deflection criteria. A greater than, B less than, C equal to, and D none of these. Now in one of the previous questions we saw that the depth of the slab is governed by deflection criteria. Hence the depth which is required for to resist the bending moment is less than, and hence here the correct answer is B less than. Question number 23. If the depth of slab provided is greater than that required to resist bending moment, it means that the slab is A under reinforced, B over reinforced, C balanced, and D none of the above. Now, whenever we are designing a slab, the depth which is provided, if it is greater than the depth required to resist the bending moment, definitely the slab will be under reinforced. Hence, the correct answer is A under reinforced. Question number 24. The effective depth of a two-way slab is 120 mm. If the diameter of the bar along short span and long span are 10 mm and 8 mm respectively, then the effective depth along longer span will be A 110 mm, B 112 mm, C 120 mm, and D 111 mm. Now we know that for a two-way slab, whenever we take the section along shorter span and along longer span, the depths will be different because longer span steel is provided over a shorter span. So you have to deduct from that effective depth, you have to deduct half the diameter along shorter span and half the diameter along longer span. So here it will be 120 minus 10 by 2 minus 8 by 2. So it will be 120 minus 9. Hence it will be 111 mm, and the correct answer is D 111 mm. Question number 25. In a slab, the distance between main bars shall not exceed the effective depth. A 4 times, B 2 times, C 3 times, and D 5 times. Now we know that for main bars, maximum spacing is 3D or 300 mm, whichever is less. Here it is asked in terms of D only, 3D, that means it is 3 times. Hence the correct answer is C 3 times. Question number 26. In a slab, the distance between the distribution steel bars shall not exceed A 300 mm, B 450 mm, C 250 mm, and D 500 mm. This is the question similar to previous question. Only difference is here distribution bars are given and it is asked in terms of distance, not in terms of D. Okay. So for distribution bars, we know that the distance between distribution steel bar shall not exceed 5D or 450 mm, whichever is less. So here the correct answer is B 450 mm. Question number 27. For a cantilever of effective depth 200 mm, the maximum span to satisfy the criteria of vertical deflection is A 1.6 meter, B 4 meter, C 1.4 meter, and D none of the above. Now in this particular question, you know that L by D for cantilever is 7. So if you substitute D as 200 mm, so L upon 200 mm is 7. So if you multiply by 200 mm, L will be 1400 mm, that is 1.4 meter. Hence the correct answer is C 1.4 meter. Question number 28. The deflection in the beam or slab can be controlled by A. Increasing the width, B. Controlling the span to depth ratio, and C. Increasing the grade of concrete, D. Controlling water cement ratio. Now deflection is most important criteria as far as slabs and beams are concerned. So if you want to control that deflection, we can select proper span to depth ratio, that is, it can be controlled by controlling span to depth ratio. Hence the correct answer in this question is B, controlling span to depth ratio. Thank you.